This video is on Review Quiz 2.6, and this is really about functions and arithmetic of functions, and also finding the domains of these types of things. So first off, let's look at this function here, g of x, and figure out the domain. The big thing about looking at domain is asking what values of x give us issues, or what do we not want to have in the function, like what things should we avoid? So first off, you see we have a fraction here, and fractions always kind of should bring about like the thought of when does it give me 0 in the denominator. In this case, it gives us 0 when x equals 10. So x cannot equal positive 10 because 10 minus 10 is 0. That's our first problem. Now in the numerator, we have a square root. And because we look at graphing these types of functions in general, that's what we're looking at. You do not want to have complex numbers because complex numbers cannot be graphed on a real plane. They're not available in a real plane. So we must look at this function on top and ask, when does it give us a complex number? That's when the inside is negative. 0 is fine. The square root of 0 is 0, which is a real number. So 0 is fine. It's just when is it negative? In other words, when is x minus 5 less than 0? That's true when, well, x is less than positive 5. So we must also exclude x less than 5. And you can see that this is if we exclude x less than 5, we must also exclude x cannot equal 10 because 10 is greater than 5, which would be included. So we're allowed to have anything greater than 5. So x cannot be less than 5. In other words, what we want is x to be greater than or equal to 5, because that gives us 0 or bigger than 0, so a positive number in the square root. But we also don't want x equaling 10. 10 is greater than 5, so it would be included, but we can't include it because it's going to give us 0 in this denominator. So you have to consider both those two things. If for some reason we found, like as a result of this thing, instead we found something like x must be less than like 2, if we found that x must be less than 2, that inherently includes that x cannot equal 10 because x has to be less than 2. But we did find that x must be greater than or equal to 5, and x equal to 10 is available in that range of values, so we must exclude it as well. We always write this in interval notation. The smallest thing we can have is 5, and it's included, so we use a square bracket. This goes up to 10. And 10 must be excluded because it gives us 0 in the denominator. So we must also union this with 10 up to infinity. That's the interval notation of what I was talking about there. Let's see, we have 5, 10 unioned with 10 to infinity. Okay. That's correct. The most important thing here, I don't want you to get confused by what I have written right here. I said x must be less than 5. What I'm really asking here is what values must be excluded, and I found that x less than 5 must be excluded. You can also ask the question, what values must be included? So in other words, when is x minus 5 equal to 0 or greater? You could say x minus 5 must be greater than or equal to 0. Well, then you just solve it the same way, and you get x greater than or equal to 5. These are the values that must be included. What I found here was what values must be excluded. So it's just a different way of thinking about it. Either way will get you the right answer as long as you understand what you're looking at. Okay, let's move on. Here we have arithmetic with two functions. The first function is a quadratic, and the second function is, I don't need to write it down. The second function is just a a linear function, just a line. The first thing we're going to do is we're going to add these two functions together. So f of x, f plus g of x is the same thing as f of x plus g of x. So we get 3x squared plus 16x plus 21 plus x plus 3. We have like terms. 16x plus x is 17x, and 21 plus 3 is 24. That's just a quadratic equation. To the power of 2, oh, whoops. One minus in there. Plus 17x plus 24. And this is a polynomial. Polynomials have everything in its domain. That's always the case for polynomials. So that's nice and easy to find the domain of. F minus g of x is the same thing as f of x minus g of x. We're just going to subtract these two functions. So we get 3x squared plus 16x plus 21 minus, and here I'm going to write g of x in parentheses. That's because when we subtract them, what we're really doing here is just saying these are both in parentheses here. Like I did the same thing for this top one, but in this case, the parentheses don't mean anything, so I just dropped the parentheses. Down here, the first set of parentheses don't mean anything. The second set, however, do, and that you have to distribute the negative. That gives us 3x squared plus 16x plus 21 minus x minus 3. Now we have like terms. Get some room here to show the answer. 16x minus x is 15x, and 21 minus 3 is 18. 3x to the power of 2 plus 15x plus 18. This is once again a polynomial. It's actually a quadratic, more specifically. But polynomials have everything in their domain. Negative infinity to positive infinity. All right, next one is f times g. This, as you can guess, is just f of x times g of x. So we have f of x times g of x. Here we have to distribute the 3x squared into both things, the 16x, and then the 21. 3x squared times x is 3x cubed. 3x squared times 3 is 9x squared. 16x times x is 16x squared. 16x times 3 is 48x. 21 times x is 21x. And 21 times 3 is 63. Combining like terms, we get 3x cubed. These two are like terms. These two are also like terms. 9 plus 16, that's going to be 25. X squared, 48 plus 21, 69x plus 63. Is that all correct? I believe so. And this is once again a polynomial, so it has everything in its domain. 25x squared, 69x plus 63. So that's f times g of x. Last one is division, and division you should always be thinking about division. When does the denominator give me 0? So we have to exclude something here. F of x is going to be, so once again, this is just f of x over g of x. That's going to be 3x squared plus 16x plus 21 all over x plus 3. And so right off the bat, we can say that x cannot equal -3 because that will give us a 0 in the denominator. Now let's move on. To solve this, we're going to simplify the top by factoring it. Let's see, we have AC method, 3 times 21, it's going to be 63 over 16. Two numbers that multiply to give 63 and add to give 16. 8 times 8 is 64. See, 63. 7 times 9, isn't it? Yeah. 7 times 9. 63. Yeah, okay, cool. That one wasn't actually that bad. For the general method, for the AC method, since a doesn't equal 1 here, we have to use the full method. Bring down the first term, 3x squared, then plus 7x, then plus 9x, then plus 21. Now we can factor by grouping. Out of the first two terms, the last two terms, we get x, 3x plus 7, and 3, positive 3, 3x plus 7, yep. And now we get 3x plus 7, and then x plus 3. That's the factored form of the top. So this is going to be over the denominator, which was x plus 3. And you see those cancel, giving us just 3x plus 7, which is a polynomial, and you would say everything is in its domain. However, in the original problem, we have that x cannot equal -3. Therefore, that's what this part is right here. It's just excluding -3 from the domain of everything. And so that's going to be our domain there. Let's check it. And all of that is correct. These are pretty easy to get wrong because there's so many parts to it. So just take your time and double check to make sure you inputted everything in correctly. All right, this is a very similar problem, except now we have two rational functions that we're going to be doing arithmetic with and seeing how to do it. So for the first one, we have f plus g. We have 3x over x minus 4 plus 4 over x plus 6. Right off the bat, we see x cannot equal 4 or -6. And to add two fractions together, we're going to get common denominators. In other words, multiply by x plus 6, multiply by x minus 4. Okay. Distribute the 3x into there, distribute the 4. Add the numerators together, we get 3x squared plus 18x plus 4x minus 16. This is all over one denominator of x plus 6, x minus 4. Combine like terms, we get 3x squared plus 22x minus 16. I believe now we can factor the numerator. Let's see, plus 22x minus 16. There's nothing I can take out of that, so there's no greatest common factor. So I'm just going to proceed with the AC method. We get -48 and 22. Let's see, it's going to be 4 times 12. I'll just start off with 1 times -48, 2 times -24, and there we go, actually. This will give me -22, but then I can flip those to give us +22 when we add them. So we get 3x squared minus 2x plus 24x minus 16. Now the first two I can take out an x, give me 3x minus 2. The second two I can take out a positive 8, giving me 3x minus 2, and that gives me 3x minus 2, x plus 8. That's the numerator. In the denominator we have x plus 6 and x minus 4. So we get 3x minus 2 on top, x plus 8 over, was it x minus 6? X plus 6. That's 4. And there's nothing we can take out. There's no common factor on top and bottom. So this is actually, we actually didn't need to do this method, but we had to do it anyways to check. We didn't know there was nothing to do to cancel. So that's going to be our full answer. I'm just going to write the factored form because I did a lot of work. I might just write it down. X plus 8. And we know we must exclude positive 4 and negative 6. Positive 4 and negative 6, that's what B is here. We're removing out the negative 6 and removing out the positive 4. The rest of it is fine though, and that's because this is really a polynomial over a polynomial. The only issues are where the denominator equals 0. So those are the only things we have to worry about. All right. The next one is the same thing except subtraction. So let's look back up here. All it's going to change is at this point right here, we're going to get a minus, and that's going to distribute into these two things. So let me just copy this down. And let's go from here. We have 3x squared plus 18x minus 4x plus 16. You can also note that x cannot equal negative 6 or positive 4 again. It's the same issues in the beginning, or as the first problem, I should say. Combining like terms, we get 14x plus 16. Now I can do the AC method. 3 times 16 is 48. Positive 14. So two numbers that multiply to give 48, add to give 14. 4 times 12 gives me 16. 5 doesn't go into there. 6 times 8 is 48. Yeah, so 6 times 8. 3x squared plus 6x plus 8x plus 16. I'm just kind of skipping forward a few steps. You can do this faster and faster the better you get at it. First two terms, second two terms, so we get 3x from the first two, gives me x plus 2. And then from the second two, we get positive 4. And now you see we get 3x plus 4 and x plus 2. That gives us 3x plus 4, x plus 2, all over x plus 6, x minus 4. Oops. Now, you'll notice that once again, nothing was canceled. So that means that the domain is going to be the exact same as the previous problem because nothing was reduced from these things. So the domain is remove negative 6 and remove positive 4, right? Negative 6 and positive 4, yeah. All right, here we're going to multiply the two things together. So this one's actually a little bit easier, I think. Times 4 over x plus 6. Still the same denominator gives us x cannot equal negative 6 or positive 4. Multiplying this together, we get 12x over x minus 4, x plus 6. And there's no reduction that we can do here. That's the best we can do. In that case, multiplication and division typically in these types of problems are much easier to do than addition and subtraction. And we still have the exact same denominator. Negative 6 and positive 4 cannot be reduced. Division is the last one here. You can see that they have a different denominator here. So something's going to reduce. And division just says the first thing divided by the second thing. oops, divided by is 4 over x plus 6. So in this problem right here, you can see that x cannot equal negative 6 and 4 again. A division, we're going to multiply by the reciprocal instead. So we get 3x over x minus 4 times x plus 6 over 4. And now we can multiply the numerators. I'm going to I'm not going to distribute. Actually, I'm going to leave it factored. That's going to give me 3x, x plus 6. You always want to leave it factored when you're doing this because that's going to let you cancel things. And as you can see here, there's nothing that needs to cancel. However, we still had the fact that x cannot equal negative 6 and 4. And nothing has changed in the denominator. This is the only thing that gives us 0 here is positive 4, but we already are excluding that, so we don't have to worry about that one. So 3x, x plus 6, and the denominator is once again the same thing, negative 6 and positive 4. Let's check it. All right, let me find my one error there, and I'll get back to you. All right, I found my error here. I did all the work correctly. It's just right here when we're doing the f minus g, I wrote, I took out a 4, and actually out of these two things I can take out an 8. So this should really be 4, or sorry, this should be 8. 8x plus 16, you can take an 8 out of those two, and that gives you x plus 2, and that's just going to give us 3x plus 8. It doesn't change really any of the domain or the answer by much. It's really just that one little change there, which makes the whole thing wrong, honestly. So that's why it's you gotta be very careful with your work. And now that's completely correct. Okay, let's move on to the next one. Here we're doing compositions. So before we had addition, subtraction, multiplication, division. With functions, there's an additional arithmetic operation we can do, and that's called compositions, where you plug a function into another function, vice versa, and you can simplify doing that. All right, so we have two functions, 2x minus 1, this is a linear function, and then 5x squared minus 2, that's a quadratic. And we're going to plug, this is called, part A is called f of g of x, and then B is g of f of x, f of g of negative 1, g of f of negative 1. The first one, we're going to plug g of x into f of x. I'll just show you that. F of g of x is the same thing as f of g of x. Just plug g of x into f of x. In other words, plug the function g of x, which is 5x squared minus 2, into the x spot of f of x. So we have 2 times x minus 1. The x is now g of x. This is going to be 2x minus 1, but now the x is changed into g of x. And we can simplify this thing down. Distribute the 2, we get 10x squared minus 4 minus 1. 10x squared minus 5. That is our first function, minus 5. Okay, very good. Next one is g of f of x. So g with f of x plugged into it. G of x is 5x squared, 5x squared minus 2. But now x is going to be f of x. We just plug it into there. And simplify. For this one, we're going to need to expand this, squared term there. So we're going to get 5 times 2x minus 1 times 2x minus 1 minus 2. FOIL this thing out. That gives us 5 times 4x squared minus 2x plus 1 minus 2. 5 times 4x squared minus 4x plus 1 minus 2. Distribute the 5 into there, giving us 20x squared minus 20x plus 5 minus 2, and finally we can combine like terms. Plus 3. So that is our second function. 20x plus 3. And now the last two, part C and D, are where you plug -1 into f of g and into g of f. In other words, just plug -1 into here and see what you get. So we can do f of g of -1 equals 10x squared minus 5. -1 squared is 1. 1 times 10 is 10. 10 minus 5 is 5. This first one's going to be 5. The second one, just plug -1 into here. -1 squared is 1, so 20 times 1 is 20. -20 times -1 is positive 20, and plus 3. That's just 43. And that's all correct. So composition like this is just plug a function into the other function and vice versa. And then in this case, they wanted actual numbers plugged in as well. All right, for the last problem, we have a composition again. And now we're going to find the domain of the composition. But here we have two rational functions. And we're going to plug them in. So the first one is f of g of x, or that's the composition we're doing. So this is once again f of g of x. Plug g of x into the x spot of f of x. F of x is x over x plus 1. So g of x, which is 11 over x, that's going to be plugged into this first x spot and the second x spot. Every occurrence of x must be changed. So f of x is x over x plus 1. But now in each x spot, we're going to plug in g of x. There's a first g of x, and there's a second g of x. So this is f of g of x. Now looking at this, this is a complex fraction. We can simplify this by multiplying everything by the least common denominator. In this case, it's going to be x, because 1 is the same thing as 1 over 1. So everything can be divided by, can be made into division by x. Before I can do that, I need to note that x cannot equal 0. If it did, we would have 0 here in the denominator and 0 here. So we must first exclude that. Now, if I multiply by x over x, that just distributes into everything. And that gives us, on the top, x times 11 over x, the x's cancel, giving us just 11 on top. On bottom, x times 11 over x is once again 11. And x times 1 is x. This is no longer a complex fraction. It's now just a regular fraction. And we must exclude 0 in the denominator, which happens when x equals -11. And there's nothing else we can do here, so this is the simplest form we can get. There's no factoring. They're both linear terms. There's no common factors that we can cancel out. You cannot cancel out the 11s, because in the denominator we have an addition that kind of locks it in. So the 11 can't be reduced. This is the best we can do. 11 over 11 plus x. And our domain is going to be from -infinity up to -11. Not including it, of course, so we use parentheses. Unioned with -11 up to 0. Not including that. And finally from 0 up to infinity. So here we've excluded -11 and we've excluded 0. So that should be our domain, and that's correct.